Okay, I hope my screen is visible. Yes, no? Okay, Darshini, thank you for confirming. So yesterday there was some disturbances, so I had to disconnect the class. I was having network issues. Okay, so we will discuss this once again. No worries. Singleton class. So our topic is what? Singleton class. Okay. So what does it says? If you take any Java class, okay, if that Java class is allowing you to create object only once. If any Java class allows you to create an object only one time, it is called as singleton class. But the question is, how anyone can achieve this? How anyone can achieve this? That is the question. Okay, we know how to create an object. Okay, for example, if I take a class A, okay, so we know that a class is a blueprint from which the objects can be created. Okay, if you have a class A, in this class you can have any number of variables, okay, and you can have any number of methods, right? So I can also say that these variables are also called as what? Properties, data representation, and methods are called as behaviors. Okay, so the idea here is the class is going to act as a blueprint from which you can create any number of objects, right? So this is how the object can be created. Object can be created from a class a obj equal to new a. So like this, you have a scope to create any number of objects. Okay, so this is called as an ordinary class or a concrete class. This is called was this is a typical class where you are allowed to create any number of objects. This is object 1, this is object 2, this is object 3, and so on. There are no restrictions. Okay, but my requirement is I want to build a class in such a way that you can able to create object only once. Okay, only one time you are allowed to create an object. Okay, we will understand this programmatically. Some people are joining now. Let me allow them. Okay, are you good to go? Type yes in the chat box. Shall we proceed? I want you all to be interactive in this session. Everyone type yes in the chat box. Everyone. Good. Okay. So just I want to keep the session interactive. That's why I'm asking you. Right. Okay, let me take an example here, guys. Okay. So usual example I'm taking. Okay. So I have two classes in the package. Okay, this is the package XYZ, and I have a class A and I have a class test. Okay, this is called as the main class. Why this is called as a main class? We are placing the main method here. Okay, inside this. Okay, I have a scope to create n number of objects. I don't have any restrictions for how many objects can be created. I can create any number of objects. It can be countless. So like that. So a obj equal to new keyword. Let me use a new keyword, new. So this is ideally one object. Like this, I am allowed to create any number of objects. So this is object 1, this is object 2, this is object 3. Okay, the moment you are creating an object, it means you are allocating a memory. Behind the scenes, what is happening actually? For each and every new keyword, a memory is getting allocated. The moment you use new, it is going to consume some memory, and again second time you're using new, it is going to consume another memory, again new, another memory. Memory consumption is happening, memory consumption is increasing. Okay, but sometimes the requirement will be in such a way that you are supposed to create object only once and use the same memory over and over again. If you get such kind of requirement in developing Java application, then you have to go for singleton class. Okay, before understanding singleton class, let us try to understand, is it really is it really a number of, three number of memory, three objects are creating in the memory? We will understand that. Okay, to understand that, let me try to print the reference variables. Okay, so this is what reference variable 1, obj1, okay, obj2 reference variable, and I have obj3 third reference variable. Okay, so we have created three objects, and I am trying to print their respective reference variables to see if new memory is getting allocated every time. Okay, so let me open my command prompt. So this is the command prompt. Let us okay, I am just changing the directory, cd space java, our usual directory. Okay, java c compilation commands -d dot test.java, isn't it? Let me save this. Okay, test.java, java space, I'm sorry, java space xyz dot test. Okay, you see the output, we get three values, three different values we are getting. So these values are not same, these values are three different values. Okay, this is the value, this is the reference variable 1. Okay, it has different address, this has different address, and this has also different address. Okay, by looking at this, we can conclude that for each and every new keyword, new memory address is getting created, means new space is getting created. Okay, suppose let us say that if this space is consuming 4 bytes of memory, okay, just an assumption, it is really not going to consume the exact memory that I'm specifying here. Just for our understanding, I'm giving this example. Okay, and this will also consume 4 bytes of memory. Okay, and this will also consume 4 bytes of memory. Okay, so totally 12 bytes of memory is being consumed. 12 bytes of memory is being consumed. Okay, but so my requirement is I will have to create object only once. Okay, I need to do that preparation, so that I will be able to utilize the same 4 bytes of memory every time. Instead of creating new memory every time, I will be able to utilize the same amount of memory every time. So there won't be unnecessary object creation and unnecessary memory allocation. Okay, so this is what let us trace this. Right. So this understanding is very, very important to understand Singleton pattern. Okay, so we may assume that these things are going good, but actually we lose the actual tracing. So what exactly happening here? Let me remove these three things. Okay, let us keep it here, no issues. Okay, so I have a class here. So the compiler job, we know that the compiler, before even performing the compilation, okay, if it is not finding any constructor, it is going to place a default constructor. Yes or no? Default constructor will be placed by the compiler. So this constructor is called as what? Default constructor. This is the compiler's job. It is not finding any constructor, so compiler will place a default constructor. Okay, we are using the new keyword for 3 times. This is first time, right? Memory get allocated, some space will be consumed in the RAM location. Okay, second time, and again it is encounter new keyword, allocate some space, internal things, these are the internal things. Okay, third time new keyword, okay, some memory is getting allocated behind the scenes. Okay, so for each and every new keyword, okay, we have defined our own reference variable. This is going to be what? obj1, this is going to be what? obj2, this is going to be what? obj3, right? So if you try to print these reference variables, you are getting what? You are getting reference values. You are getting what? You are getting reference value as like this. For obj1, this is the reference value. For obj2, this is the reference value. Okay, for obj3, this is the reference value. Okay, the moment you find if the reference values are different in nature, if the reference values are completely different from each other, okay, it means 3 memories are getting allocated. If you find all the reference values are equal, same, then only one object is created. So we are not able to achieve singleton pattern, but this is what happening internally. We need to do the restriction. We need to do what? First thing is we need to place a restriction for the object creation. Okay, so we will do that now. Okay, let us take this program. This is the ideal approach to create an object, but we need to develop a program in such a way that we are able to create object only once, not 3 times. Okay, approach one. Okay, this is a bad approach because 3 times object is getting created. So this is a bad approach. We want to create, we should be able to create only object. Then you might be thinking, I can do like this. I can just create one object. I can do like this. No, that should not be the case. Okay, you should not have any loopholes. Even I cannot type something like this. I should place some restrictions like this so that I cannot type something like this. Right? Second approach. Let me remove all this. So don't you think that the problem here is with the constructor? Okay, the constructor is what? The default constructor. So this is what the default constructor, because developer is not specifying any constructor, so that's why the compiler is coming into picture and it is adding the default constructor. It is default by pronunciation. Okay, so now what I'm trying to do here, I will define my own constructor, no parameterized constructor. Okay, but I will place a restriction. What restriction I will place? I will say this constructor is a private. The moment I say this constructor is a private, there is no scope for me to do the object creation. These things are not possible. Yes or no? This is not possible. This is also, these things are not possible. You cannot create an object of a class when the constructor of the class is private. This is not possible. Object creation is not at all possible. Why it is not possible? Let me run this. See, A has private access in A. So this is, it says constructor is private, so you cannot create an object for the private constructor. Okay, so we are able to place a restriction. What restriction? By defining constructor as a private. Object creation is not possible, but I need to create object only once. What is our requirement? I want to develop a singleton class which says, so this class will allow us to create object only one time. But here if you see that, if you compare that theory with the program that we have developed, okay, we are not able to create even one object, but we want to create at least one object. There is a lot of difference. Okay, here we are achieving what? We are achieving no object creation. Achieving no object creation, but we want to create object at least once. Because that is what a singleton class is. Okay, for that what I will do, I will create a instance factory method. Just try to focus here. Everyone focus here. Okay, I'm going to do what? I will create a method. Just assume that this is a method. I will create a method. Okay, this method, okay, will have a functionality inside, will have a behavior in such a way that it will create object if the object is never created. Only once. It will create object if the object is never created. If the object is already created, it will return the same instance or same reference. What does it really mean? Okay, this method is going to talk about some behaviors. Okay, inside this, the first behavior says, I am going to create an object if the object is never created. If the object wasn't created, I will create object. Okay. If the object is already created, I will return the same references. There is a lot of difference. Okay. This particular piece of pseudo code says, okay, I will create, if it will create an object if the object is never created. How does it know that it will create an object? How does it know that the object is never created? We will perform a conditional check here. There will be if condition. Okay, this if condition will pass some condition. Some condition we will pass. Okay, this condition, some condition is going to return true or false. Okay, if it is returning true, it means object was never created. So this piece of code will get executed. Okay, and another pseudocode. Okay, if the control is never going inside. Okay, if the condition is found to be false, the condition is found to be what? If the condition is found to be false, okay, anyhow this piece of code will never get executed if the condition is found to be false. If the condition is true, this piece of code will get executed. If the condition is false, this piece of code will never get executed. Directly this will get executed. Okay, we are doing a conditional check. This method is going to do some conditional check whether if the object is already created, return the reference. If not, create the object. Okay, how we can implement this pseudo code in the real-time example? You will understand that. Okay, so I am taking a variable here. Focus here. Till now we are discussing about the constructors. Now I am taking a variable. Okay, the variable looks like this: static private static a equal to new a. Okay, usually how do we write variables, guys? We know that. How do we write usually variables? This is how the variable looks like. This is what we have seen. Okay, integer a equal to 100, like something like this. Yes or no? Like private static integer b equal to 200. Okay, these are the variables that is storing the raw data. So this is a numerical value. So we need to use what? Integer data type. If you want to store the floating point value, we need to use the floating point data type. Doesn't mean that, okay, our variables can be created only on top of primitive types. It doesn't mean that. You can also define a variable for what? You can also define a variable for the object creation. You can do this. A obj equal to new a. 100% possible. Okay, this is the value according to Java. From the Java perspective, this is the value. This is a reference variable of what type? Class type, right? So if I do this, private static, let us say string a equal to Java. This is a data. This is string type. This is the reference variable. Okay, of what type? String type. Values of string. This is what? This is a object creation reference value of what type? Class type. Right? So I have defined a private variable and as well as a static variable, but not the primitive type, object type. A obj. I am not defining the value. I am not performing the object creation here directly. Instead of this, I am assigning a value like null. I am assigning what? I am assigning a value null. Right? So I have a variable, I have a constructor. This constructor, okay, this constructor is meaningful constructor. Why it is meaningful? It is placing some restriction for the object creation. Okay, you cannot use the new keyword. Okay, you may see that, okay, this constructor is useless, but not. This constructor is a meaningful constructor displaying some restriction. Okay, we have taken a variable, we have taken a constructor. Okay, before even proceeding with the, let us understand what happens if I don't define this variable. I have a constructor. So next thing is I am taking a method, static method of type A, get, the name of the method is get reference method. Okay, this reference method, okay, this reference method is helping us to create an object within the same class. Okay, A equal to new A. Okay, return A. Return what? Return A. Okay, let us understand the logic behind this method. Let me open the paint screen. Okay, so this is our method. Okay, this is our method, right? So let us try to do some postmortem on this method. So this is what? This is static. So it means it's a static method. This is the return type of the method. Return type is A itself. This is the name of the method, get reference. Okay, and inside the method this method is helping us to create object. So now tell me one thing, guys. If this method is getting called for one time, okay, if this method is getting called, I mean if I am calling this method for one time, okay, request method call, this is what a method call, typical method call, a method call. When I make a request to call this method for one time, okay, what are the instructions inside? First instruction is object creation, new keyword. Okay, because of new keyword, a memory space will be created, right? And it is going to have a variable A, right? It is returning what? It is returning the reference itself. It is returning, right? And if I call this method for the second time, okay, and again, okay, all the instructions inside the method will get executed, and again because of the new keyword will be encountered for the second time. From the code point of view, we are able to see the new keyword only once, but while doing the execution, okay, the new keyword execution depends upon the how many times you are calling this method. If you call this method for the first time, it is encountering the new keyword. If you call this method for the second time, it is encountering the new keyword once again. If you call this method for the third time, it is encountering the method new keyword for the third time. For each and every encounter, the memory is getting allocated. Yes or no? Okay, so since the variable since the constructor is private, I have taken this approach. Okay, so this is instance factory method. I have taken an instance factory method which is going to give me the object reference, because I cannot do this outside, right? I cannot do this here because this is a test class, but I am creating an object for the class A, which is what? Private. The constructor is private. I cannot do this. That's why I am trying to create the object in a indirect way. Now what I can do, let me remove this. Okay, if I ever have to call this method, this is a get reference method of what type? Of class type. Okay, static methods can be called out. This is the syntax. Class name dot method name is the typical syntax to call the static method. Right? What is the class name? Class name is A. Can I do like this? A dot, what is the method name? Get reference. Okay, if I call this method, this method is returning the object reference. This returns what? Object reference. So I need to extract that. I need to store that. Okay, so I am using a variable to store that. That is what? obj1. Okay, obj1. I am assigning. So this is a important class type. Very simple. We have studied about the method return types. Okay, so we use what? We use the respective reference value that we receive here. Okay, we will define the same primitive type. So if you place integer here, you need to define integer here, int here. Okay, if you place float here, okay, this should be float. But you are placing what? You are placing A here. So that's why this should also be A. As simple as that. Okay, what is happening here because of this instruction? Okay, get reference method is getting called, and the moment you call this get reference method, it is going to return you what? Object reference. Okay, if you call this method for 3 times, this is first time, this is second time, and this is third time. Okay, we think that the object is not getting created directly, but we are able to create the object indirectly. But still, so 3 memories are getting allocated. Why always 3? You can take any numbers, no issues. 4 new memories will be get allocated. Where is the proof? If I run this code, okay, I need to print this, right? System.out.println, right? Let us print all the reference variables obj1, and we have obj2, and we have what? We have obj3, and we have obj4. Okay, let us do the execution here. Okay, by looking at this answer, okay, all the addresses are different, right? All the addresses are not identical, they are different, they're not similar. By this we can conclude that again this is creating new object every time. What is our requirement? Object should be created only once. We are close to achieve that, but still we are too far. We are close to achieve our actual requirement, but still we are too far. We need to do one manipulation so that it can be achieved. Let us put this approach 2 here. Approach 2. It is also not successful because every time new object is getting created. Why new object? How do we know that new object is getting created every time? All the memory addresses are different. If all the memory addresses are same, it means same object is being shared, but it is different. Don't you think so? Okay, so now go back to our example. Okay, so we are not able to achieve this by using what? By just using factory method, static factory method. Static factory method. So we are not able to achieve this by just using static factory method. Okay, I need to use a variable. I need to go for this. So what it says, it has to, the method has to create an object if object is never created, or else it has to return the object reference. So this is a conditional check. To achieve this conditional check, what I am trying to do here, instead of creating object here, okay, let me remove this. Okay, what I'm going to do, I'm going to take a private static variable and I am assigning it to null. Initially I am assigning it to null. This is static. Just remember, this is a static. Okay, and here I am performing a conditional check. What I am doing here, if what I am saying, if a equal to null, okay, if a is found to be null, it's already null. A is found to be null, then do what? Do the actual object creation. A equal to new a. Hello, is there any issues? Is there any audio issues? Video is clear, guys, for everyone. Screen sharing is clear. Okay, Chaitanya, you log out and log in, Chaitanya. It will be better. You rejoin, Chaitanya. It will be good. So what I am doing here, if a equal to null, we create the object. If not, return the reference variable itself, return a itself. Okay, this will make more sense if I run this code. Okay, so I have placed a conditional check here. At the same time, I have included what? I have defined a static variable of object type. Okay, here I am doing the conditional check. Now see, because of these changes, what we are achieving, guys, because of the changes, we run this code, okay, something will happen. Don't you think that we are able to get what we have achieved what we want? All the reference values of an object are found to be same. It means only one object is created behind the scenes. What is the proof? Don't you think that all the values are same? Everything is same. Previously it was different, means different objects. Now this time everything is same. So only one object is getting created. Okay, you will understand this better. Now I'm going to trace this. Focus here. Very important. Pay some attention. You will understand this better now. Okay, let us do the actual tracing. What is happening behind the scenes? Okay, this is the singleton class. This is not this. This is a test class. This is the singleton class. Which class? Class A is a singleton. It has become singleton. You can define this class as singleton. Why singleton? You can create only one object. We have achieved that. Okay, so achieving is okay, but understanding is important. So I am doing the tracing. Focus here. Okay. So this is my code. What is happening here? Okay, let us take the new. This is my code. This is our output. Okay, let us define. Let us separate this main method. Okay. Okay. For the better observation. Okay. Okay, this is the code. This is the main method. Okay. Now we focus, guys. Okay, we will start from the beginning. We'll start what? We'll start from the beginning. Okay, what really happens? Okay, we do the compilation, we do the execution. Okay, so we need a compiler. So I'm taking a compiler. The job of the compiler is to what? It is going to generate how many .class files will be generated here. Okay, this is the compiler. Okay, compiler is going to generate. It is going to do the compilation task as well as it is going to generate .class files. How many .class files it will generate? Two .class files. One is a.class. Second one is test.class. Okay, since there are two classes, so two .class files will be generated. Okay, now JVM will come into picture. Okay, JVM is going to come into the picture. Okay, so JVM, look at the command here, guys. So this is the command I have used for what? Compilation. Okay, so compilation command is very straightforward, right? Let me mark it as a red. Okay, because of this command, compilation has started, and it has checked the instructions and the syntactical errors. Okay, if it is error free, a.class file and the test.class file has been generated. Okay, then what is the command for execution? I'm starting it from the beginning. Okay, so this is the command for what? Execution. xyz.test. Okay, so we are trying to execute a .class file of what? Test. We are specifying the test class. It means test.java file will be loaded inside the memory. Yes or no? Okay, this is going to be loaded inside the memory. Memory means I am talking about JVM. You can say it as memory, no issues. Okay, and after loading test.class file, the main thread will be created. Main thread is going to execute all the instructions inside the main method. Okay, now you see the main thread is surprised to encounter first instruction. First instruction says, okay, first instruction we have completely dependent upon class A. There is a class A dependency. A dot get reference. A is what? Class A. A obj1 what? Class A. Okay. So class A dependency is there. So in the runtime, it is going to load what? It is going to load A dot class file. Yes or no? A dot class file will be loaded inside the memory. Yes or no? A dot class file will be loaded. Runtime dependency. At the time of loading this dot class file, dot class file, static blocks and static variables will be recognized. Yes or no? Right? So we have one static variable. There is no static block. Of course, we have static method. This is different thing. Okay, this will be called at the time of what? At the time of calling only. Right? But this has to get recognized and executed at the time of loading the dot class file to the memory. A dot class file will be loaded to the memory. At the time of loading this dot class file to the memory, this has to get recognized and executed. Yes or no, guys? Static variable should be recognized and executed. Okay. So now it is going to allocate a memory in the method area. Okay, this method area is part of the JVM. We know this already. We have discussed these things already in our previous sessions. Method area is one of the memory areas in the JVM. Okay, it is somewhere inside the JVM. Okay, we will understand this exact location in the Java class. I mean JVM architecture. Okay, so this method area, I am just zooming it out. Okay, for the better observation, it is going to load the store the static content. So a so the value of a equal to null. A is of what? A type it, so it is null. Done. At the time of loading a dot class file, this recognizes as happened behind the scenes. Okay, and this instruction is also calling what? A dot get reference method. A dot get reference method. Okay, don't you think that the control will jump to the get reference method, right? And it will execute the first instruction inside the get reference method. What is the first instruction? Conditional check. Typically a conditional check. What is it checking? A equal to null. What is the value of A here? Null itself. A value of A is null itself. Don't you think that this conditional check will be satisfied because of the value A we have already assigned as null. So null is going to be compared with the null itself. Direct comparison, don't you think that is going to return true? Null is going to get compared to null itself. Of course, it is going to return true. When it is returning true, this piece of code will get executed, right? Okay, what does the execution says? Now the new keyword, it is encountering a new keyword, new A. Now object is getting created only once. So this object will get created in which area? In the heap area. Remember that. Object will be created in which area? Heap area. So heap area is another memory area inside the JVM. We know these things already. Okay, all the things that we have discussed so far will be useful for our future topics. So this is how the heap area can be imagined. Okay, so heap area is a very big area. For the imagination purpose, I am doing it like this. Okay, so let us zoom it out. This is the heap area. Inside the heap area, because of the new keyword, an object is getting created. Okay, and this reference value is going to be what? A itself. Okay, you don't worry about this reference value. Usually this A will be in the stack area. So for the better understanding, I'm taking it here. One object is created. Right? So the control, because of this control, okay, because of this conditional check, it is found to be true. So this has got executed, right? And the object is created, and at the same time, don't you think that this null will be replaced with what? New A. Previously it was null. Okay, as soon as it encounters this instruction, okay, the value of null has been changed to what? Has been changed to new A, static variable. It has changed. Don't you think so? Internally it has changed. New A. Right? so after this instruction, okay, it will come out of the if condition, and this is returning a itself. This is returning what? A itself. A is what? The reference value. Reference value of what? Reference value of this object, this a object. Okay, that reference value is what we are seeing here. Internally, this is what the generated reference value. Okay, this is the reference value. Okay, this reference value is part of the stack area. Okay, so this is the reference value pointing to this. So this reference value will get will be assigned to obj1. It's getting assigned to what? Internally, it is getting assigned to obj1. Obj. Right? And again, execution of static get reference method has been done. Okay, the control will go back here, and the first instruction has been completed. Second instruction is again what? Get reference method is getting called. Okay, the control will go back. This time the dot class file will not be loaded. It will be loaded only once. We have discussed these things already. Okay. Go back here, execute the get reference method. Now look at this. In the second time, this conditional check will be failed. Why it will be failed? Now the value is new a. The value of a is what? New a. It is not null anymore. It is not null anymore. For the first time it is null. For the second time it is not null anymore. Okay. For the first time this will be true. For the second time or for the remaining times it is going to be false. It will get executed only once. After the first execution the value got manipulated. So every time it will encounter return a, because this if condition will be failed. So every time it will return a. Return a to what? Return a to obj2. Okay, so again this obj2 is going to point to the same value. Obj2 will also point to what? Same reference value. Okay, again third time, what is it? Third time, the same instruction. Okay, same instruction, and this will go and execute the get reference. Third time also it is going to be false. This if condition will never get executed. It will get executed only once, for the first time. After the first execution, that's it. There is no chance for this control to execute the flip, because for the remaining times it is going to be false forever. Every time it is going to return a. A is going to be what? New a. So new a in the sense the object is already created. Okay, it is going to return the reference value. Okay, for obj3 also same value will be returned. And for obj4 also same value will be returned. Even if you create n number of objs, n number of objects, same value will be returned. Okay, same value for n number of objects, same value will be returned. Returned for n number of objects. So don't you think that in the heap memory only one object is getting created, and this object reference variable is being shared for all the new object, for all the remaining objects we are just trying to use the object, same object references. Same object references is being shared. So don't you think that the memory is going to be saved? At the same time we are achieving the reusability. So why we need to use objects unintentionally, I mean deliberately, without any much scope? There will be situations where you will depend upon only one object. This object reference will be you keep using this object reference every time. So that's why we are getting the same value in the output. You go back to the output and see all the values are same. Right? Making sense? Yes, no? It will make more sense if you practice. Okay. So this is what the approach 3 we have successfully achieved what? The singleton class. Are we good, guys? Yes, no? Any confusion? Confusion will be there. I trust me. In the first attempt, you will not understand, but if you take pen and paper and practice, definitely you will get this in the second attempt. Shall we proceed further? Come on, everyone, type S in the chat box. Hello. Everyone, type. Yeah, the reason why I ask you to type every time is in my previous Java sessions. Okay, so there are people, they just turn on the laptop, they just go. Okay, laptop, and they just go. Okay, and so I just don't want to happen that 1 second. That's why I just keep the session very interactive. Sometimes people will listen by lying down on the bed, and laptop will be placed on their stomach, and they will be listening through the classes. So I do not want you to do that, and also try to always carry pen and paper with you. Okay, so you have to learn, by the time the classes are going. So it will make more sense, and you will get more confidence. Okay, shall we proceed? I will proceed now. Okay. Okay, these things will be included in the notes. You do not have to worry about that. Okay, so now what we have achieved, how to achieve the creating the singleton class. Very important questions. If you are able to answer this question in the interview, usually you don't get this question because this is an advanced topic, but I have included this topic in my syllabus. Okay, but there are chances that if you get this question and if you are capable to answer to this question, definitely they won't ask you any other questions. Right? Only experts can answer this. Right? So stay focused. First thing, how to achieve creating the singleton class. So we need to declare the constructor as private. Declare the constructor as private. First thing, constructor should be private so that object, direct object can't be created outside the class. You cannot create the object directly if you declare the constructor as private outside the class. Secondly, declare a private static variable to hold the object reference. It can be null or it can be anything. So what does it mean is, this is what it means. This line. Okay. Second, okay, this is what talking about this constructor line. Simplest. Okay. And the third point. The third point says what we have done after that. We have defined a method. What method we have defined? We have defined a static method. Right? Define a static instance factory method. Why factory method? We have discussed about the factory method topic in the previous class. Justifies that. So it is helping us to create an object. It is helping us to get the object reference if the constructor is private. So we are trying to get the object reference indirectly because the constructor is private. Directly is not possible. Indirectly we are creating a method. That method is doing this. That method is helping us to do the object creation. To return the object reference variable for one time with the right conditional checks. It means if the object was never created, it would create, else it would return the same object reference. So this is the ideal example of the static factory method. Okay, static factory method. Okay, these are the three rules that if you focus on these three rules, you'll get. And again, there are two more things that you should aware of. Okay, so there are two types of initializing the singleton classes, or initializing or defining the singleton classes. There are two ways, I can say. There are two ways to instead defining the singleton classes. Okay, one is eager initialization, very important. Okay, second one is lazy initialization. Very simple, very simple. Don't worry about the words. Okay, these words may look complicated, but ideally it is very simple. Okay, so what does it mean to be an eager initialization? We'll understand. When you create the object at the time of loading the class file to the JVM, then this concept is called as eager initialization. Okay, what does it mean? Go back here. At the time of loading the .class file, earlier we have defined this as null. Okay, so initially it will be null. Later, due to the conditional check, object will be created once, right? For the second time, it is going to return the same instance. Okay, this will happen only once, the first time, right? Do you think it will happen? This conditional check will be executed for the second time? No, only one chance is there, right? Instead of doing this, I can, instead of assigning a value as null here, I can do new here. I can create object only once here. Okay, I can create object only once, right? And then I can return the instance directly without any conditional check. Object is created at the time of loading the bytecode to the memory. Only once it is created, I'm returning the same instance. The moment this method is getting executed, it is going to return the same instance. Will this example work? One minute, guys. Are we getting the same value? It means it is working, right? This is called as what? The eager initialization. Why eager? You're loading you're getting the object at the time of loading the .class file to the memory. So I just want to recheck this. Okay, you're getting the same values, right? So let me remove one thing. Yes, success. Okay, very simple. Code has been now there is much clarity in this code. At the time of loading the .class file to the memory, object is getting created. So behind the scenes, instead of giving the null value in the beginning, no, don't give the null value. Why you want to give the null value? Directly create an object. Directly do the object creation. A equal to new A. Directly do this. If you do this directly, you do not have to do these null checks. You can skip this. Directly return A. Directly return A. Object is created only once, that is taken care by the static variable. Okay, next time return the same references. No, we do not have to do the conditional check. Why we have to do the conditional check? Not necessary. Yes or no? Right? This is an example for the eager loading. This is the example. Problem statement. Right? Everyone, people who have joined, if you get logged out of the meeting, try to rejoin. Okay, that the meeting has been set only for 1 hour. So try to rejoin after 9 p.m. If you get logged out. Okay. Okay. So this example, please be informed that we have declared a private static variable to generate the single object or instance for the class at the time of loading the .class file to the JVM. Right? And the constructor has been defined as private to restrict the object creation from outside the class. We know this already. And in addition, the static factory method is used to return the same object reference during the method call. During the what? During the method call. This is called as what? Eager ins. Very simple, no? Eager initialization. Only one change. No conditional checks and no. Only one change. Okay. The second thing is lazy initialization. Lazy. Lazy initialization. Okay, what is lazy initialization again? Any idea? Any idea? Very simple. This is really, previous example is lazy initialization. As simple as that. Lazy means you do what? You assign this to null. Guys, just confirm if my voice is audible and screen is visible. Let's wait for the people. Are we good to proceed, guys? Yes, no? Okay. Okay, lazy initialization is nothing special. Okay, if you do this, if you assign initially as null, and if you do conditional check. Previous example is what? The lazy initialization. This is the lazy initialization. The previous example, the same previous example is called as lazy initialization. Okay, I can take the same example and I can place it here. Okay, nothing new. The example that we have analyzed is lazy initialization. That small change. What is that small change? Adding, instead of null, adding new a and removing the conditional check is called as what? Eager initialization. Right? So lazy initialization stays. You can copy and paste this. Okay. Okay, sorry for the delay, guys. Lazy initialization. Okay, unlike in the previous example, we don't initialize the variable first, and we initialize the null value at the time of maybe null value. The null value will be assigned at the time of loading the dot class file to the JVM. This concept is called as what? Lazy loading, because for the first time the value is null, and for the further executions, okay, the value would get a reference. The variable would get a reference value. The variable, instead of saying the value is null, the variable is null, right? To achieve this, we do what? We use some conditional checks. Simple, very simple. No? To achieve this, we use what? Conditional checks. Okay, but there are some cases where you would prefer the lazy initialization, and there are some cases where you would prefer the eager initialization. That you do not have to worry about this, but these are the two initializations that we have in the singleton class. These are the only two initializations that we do have, where we do have in the singleton classes. Right? There are many solutions. Okay, this is one of the solutions. There are many solutions. You can create your own solution. Okay, so this idea has been developed by, okay, this singleton class is an idea provided by singleton design pattern. Okay, please be informed that the idea of singleton classes is provided by singleton design pattern. Okay, the singleton design pattern is language agnostic, which means it is not only related to Java. This design pattern concept is related to all the programming languages. It is not only applicable for Java. Design patterns are the concept that is applicable for all the object-oriented programming languages, not only related to Java. In Java, this is how we can achieve. In Python, the steps are same, but the syntax is going to be different. As simple as that. Right? I think the concept of singleton design pattern is very clear, and you can also do this kind of comparisons can be like, okay, instead of printing this, okay, I can take two reference variables, okay, A and B. Instead of doing all this, okay, A and B, I can do a conditional check, like is obj1 double equal to obj2. We have created two object reference values. If both are same, okay, if both are pointing to the same object, it is going to return true. Okay, this is going to be executed. System.out.println. Both objects are same. Instead of printing the values, I can do this kind of checks. Okay, obj1, obj2. If both are same, output is going to be both objects are same. This is the confirmation for us that both objects are pointing to the same references. You can create any number of objects. You can also do this. obj3, obj4. Output is going to be what? True itself. Don't you think so? Both objects are same. Right? This is another example. Okay, I will include these examples in the notes. Okay, and this is the complete explanation about the singleton class in Java. Just revise this note, do some revision, do some practice. Okay, these things are very easy once you get used to this. Okay, this will be in your hands. Okay, any questions for me, guys? Are we good to wind up the